My name is Landon Gray from the Programming Committee, and our next speaker is Meagan Waller. Meagan is a senior software consultant at Testable, easing engineering pain points and promoting sustainable code and delivery. Outside of work, she enjoys Survivor, she's a Vim tinkerer, and a board game enthusiast. Please give a warm welcome to Meagan Waller.
Hello, everyone. All right. Today, we're going to be talking about Ruby on Rack. I call this Ruby on Rack : the magic between request and response. But before we get into that, I want to take you on a trip down memory lane, back to a time when the internet was a mysterious realm filled with endless possibilities and websites loaded at the speed of an entire test suite run. Before I heard of the internet, though, I was just fascinated by computers. This is me in my family's computer room. We all had one. I loved playing games on the computer. I loved just messing with it, typing on the keyboard. One of my favorite things to do was to play games on floppy disk. The Wheel of Fortune game was my favorite game. I didn't know any of the clues. They were all for like obscure movies I had never heard of. I was 4 years old. But since it was just a floppy disk, there's obviously only so many puzzles that they can fit on that. And once I figured out all the puzzles and I was able to complete them all, I decided it was time to play other games. And a game I really liked to play was spreadsheets. I would balance a budget for a pretend family. That was a fun game I loved to play. I just wanted to be on the computer. But this was pre our family getting the internet in our house. But we eventually did join the rest of America, and we went online. You see, it all started in 2004. I was a wide-eyed 12-year-old, and I had a mission. My mission was to make my Neopet shop adorable and glittery, mostly glittery. I remember crafting my first line of HTML in Microsoft Notepad, and that moment was amazing to me. I was taking letters, and then it was doing something on the internet with just typing in it. It felt magical. I started finding tons of websites made by girls not much older than I was, and they were mostly teaching other girls how to write code. Some of this code was like very specific to Neopets. Some of it was just code in general. This was one of my favorite websites at the time, codegirl.com. And so I built my first website. Here it is, skyblue.com. And I also created tutorials so I could teach other kids to write code too. So let's fast forward a bit from my initial foray into web design. There was like this pivotal moment in my preteen web career. So let's picture this. 13-year-old girl who has been spending lots of time making websites, but maybe is looking for something else. She might write like a bold declaration like, I've lost all interest in web design and I got a life. So leave me alone, not coming back. So did I get a life? Did I abandon the mesmerizing world of web design for something else? Well, I'm sure the suspense is killing you, but I'm still here. I'm talking to you about web application development today. So turns out I did not get a life, and I am still here. Still mostly want people to leave me alone, though, so that didn't change. So apparently I'm still on that quest for the perfect balance between my glittery Neopet shop and like everything else. But why am I sharing this with you today? It's not just a trip down memory lane. It's a metaphor for our journey here. Much like my quest to beautify my Neopet shop, I've always been curious about what happens behind the scenes on the web. That curiosity led me to explore the magic of web development. And today it leads us to a different kind of magic, the magic of Rack. Just as I dove into the code to make my Neopets page play music automatically with no way to easily make it stop, today we are going to delve deep into the heart of Ruby web development itself and uncover the secrets behind Rack. So, are y'all ready to discover the magic between request and response? Let's embark on this adventure together. So, this is where our journey is going to take us. This is the TIL web application, a fun playground that showcases the capability of Rack. Before we dive into Rack, I'm gonna let y'all get like a sneak peek of what we're gonna be building. It's a pretty straightforward interface, yet it encapsulates the magic of web development with plain Ruby using Rack. So the thing that makes this app TIL tick is its Rack-powered features that bring the application to life. We're talking about WebSockets for real-time interaction, template rendering for dynamic content, and custom middleware for flexible request processing. Each feature is something that we can do with just plain Ruby using Rack. If you want to check out the application, feel free to scan the QR code on this slide. As we unravel Rack, you can use this app on your device to let me know what you've learned. If you'd like to share, you can type it out in the text area, or you can just press the button that says, I learned something. But before we get into that, we're going to dig more into what Rack is all about, what it proposes to do, and what it does for us. So you might be wondering why Rack is even worth exploring. Rack is the unsung hero that forms the backbone of Ruby web applications. Think of it as like the foundation that all of our popular web frameworks like Sinatra, Rails, Middleman, all of these are built on top of Rack. So this is a quote from Christian Newkirchen's blog post introducing Rack in 2007. So Rack set out to provide a minimal API so that we can develop web applications in Ruby. It connects our web servers and Ruby web frameworks. Tongue twister. So we're gonna zero in on that minimal API part to start. The beauty of Rack lies in its simplicity. Here we have a straightforward Rack application. In just a few lines of code, we define a class called myApp with a call method. The call method expects a few things. First is the environment object. This is an instance of an unfrozen hash with CGI-like headers. The Rack application is free to modify the environment. The environment includes information like the request method, the query string, the server port, as well as several Rack-specific variables like Rack session, logger, the Rack input stream, and you can see everything that the env is comprised in the Rack spec documentation. The response for a Rack application has three parts. First is the HTTP status. It is required to be an integer greater than or equal to 100. Here, I've set it to 200, so we get that OK response. The next thing that the response provides is our headers. This is also an unfrozen hash with string keys. There are some special headers starting with rack dot, which are for communicating with the server, and they should not be sent back to the client. The content type must not be set when the status is like a 100 status, 204, 304, and the content length shouldn't exist when the status is a 100, 204, or 304, any 100 status. The last thing that we get in our response is our body. This is typically an array of string instances and a numeral that yields string instances, a proc instance, or a file-like object. The body has to respond to each or call. A body that responds to each is known as an enumeral body, whereas a body that responds to call is going to be one of our streaming bodies. As you can see, the minimal API of Rack allows us to create web applications with incredible ease. But Rack doesn't stop here. We're going to zoom in on another crucial aspect of the Rack mission, connecting with web servers, because Rack acts as the bridge between your Ruby web application and the web server. So, as we know, we have tons of Ruby web servers like Webrick, Thin, Puma, Unicorn. Rack allows us to run efficiently across these different server environments because it provides us with this great server interface. So we're going to take a look at this snippet, and we're going to see how we can connect with different web servers. We're using Puma here. Puma we just initialize this here with the rackup handler, and we run Puma with our app, and we can set it to the port that we want. There's other options that we can set as well. And now we're telling Rack to run our application using the Puma server. This bin rackup is going to kick off our config.ru file. So Rack seamlessly integrates with various web servers, so you can choose the server that best suits your application's needs. And the proof that this is actually working, this is technically a web application, and it's not very interesting, but still impressive, right? We did this with just that one method. So here we're using the WebRick server, and we can see that it's just as easy to swap this out, replace Puma with something else. And when we run our rackup, we see here that WebRick is what we're doing with the HTTP server start at the bottom line here, and putting that on port 9292. And no different to the end user, but we know that WebRick is the web server that we're using. So we're going to dive a little bit deeper into what happens behind the scenes, because like I said, Rack does provide us with a web server interface that abstracts away many of the complexities with server communication. The abstraction is a key factor that makes our lives as developers simpler and more efficient, and allows us to focus on writing the web application code. So here is an example of the WebRick class in the rackup handler namespace. So the way that this interface in Rack works is it handles all of those like tedious tasks, like initializing the servlet, managing the request response cycle. At the heart of Rack is this web server interface. This interface defines a standard way for web servers to communicate with Rack applications. So we're going to take a look at how this abstraction simplifies the process. So down here, we see that Rack initializes the WebRick server with the provided options. And these options can include things like the host, the port, SSL settings, et cetera. Next, we see the server mount line. Here, Rack is telling WebRick to route all incoming requests to our Rack application app. And then the slash path indicates that our Rack app will handle requests at the root level. Finally, we're either going to yield the server to the block if it's given, or we're going to start the server. And at this point, our Rack application is up, it's running, it's ready to go. So this process kind of encapsulates the elegance of Rack's approach. With just a few lines of code, we configure, connect, initiate the server, abstracting away all of the complexities and allowing us to focus on what matters most, building our web application. Now we're going to zoom in on a little bit of the inner workings of handling requests in Rack, particularly through the Rack request class. This class handles parsing and provides access to the details of incoming HTTP request. Understanding the request is very important so that we know what to respond with. So we can gain insights by exploring the Rack request class. Before we get into that, I have a little confession. I'm a total puts debugger. When I want to know what's happening inside of the Rack request class, I am going to go straight to the source. I will sprinkle some puts directly in the Rack library itself, and I will have cloned a version of it and then set my gem file path to that version so that I can mess around with it, see what's going on. This hands-on approach has been my secret weapon to understanding the nitty-gritty details of Rack, but also just like other gems as well. I want to get in there and see what's going on. So I have these put statements here, so I'm going to put out the environment at the Rack request initialize, and then also inside of the env namespace. So when I kick off the server, we can see what the environment looks like at this point. There's lots of other places that we could also put these puts requests, but this is not also the full environment, is much longer than this, but there is a lot of information here that we can use. So let's take a moment to kind of like reflect on what we've learned so far. So we've seen Rack's minimal API. We've seen how we can easily create web applications with whatever server makes the most sense for us very easily. And the next thing that Rack provides for us is these Ruby web frameworks are what's built on top of Rack. So understanding Rack can help you to understand more about Rails or Sinatra or Middleman or whatever you're building with. So we're going to explore those 3 frameworks today, and we're going to see how they leverage Rack. And each of them have their own flavor of how they handle this. We're first going to start with Sinatra. So Sinatra is the micro framework, and we're going to dig into the source code to see how Sinatra kicks off its Rack application. First, though, we can see that Sinatra leverages Rack's request and response classes by inheriting from them. But in our initialization, which is our build here, we are actually kicking off the Rack builder. And then we are using that to transform it into a fully fledged application. Middleman's up next. Middleman, static site generator, and also uses Rack for its application initialization. First, we have essential Rack middleware for ensuring compliance with Rack specs and handling HTTP head request. Next, Middleman dynamically incorporates any additional middleware configured by the user, and then the root URL is mapped to the Middleman application, setting the foundation for routing all incoming requests. Additionally, custom path mappings are accommodated. And then finally, the application is returned. I didn't include that, but it's just app at the bottom. All right. And here we have Rails. So at the heart of Rails, we have this app method, and this is responsible for initializing the Rack application. Rack uses this lazy initialization strategy, ensuring that we're only building our Rack application when it's needed. Next is the construction of our initial middleware stack. The default middleware method is called, setting the foundation for subsequent configurations, and then middleware configuration is next. Rails merges additional middleware configurations into the existing stack, and then finally the Rack application is built using the configured middleware stack and then the designated endpoint. So now that we've learned about Rack's reason for existence and how it provides us that nice interface for abstracting away all the not fun parts of web development, the true beauty of Rack, in my opinion, is how intuitive it is to compose even more powerful applications by stacking Rack apps in middleware. Let's take a closer look at what we mean by apps and middleware and how we can use them to sort of puzzle piece our way to a web application with minimal dependencies. So here's a piece of custom middleware that I wrote. It's very simple and pointless. What this middleware does is it is going to change every URL that gets requested with foobar instead. But this is something we can do with middleware because we initialize it with our Rack application. That means that we'll have access to it, and we can let middleware do its thing to it, and then pass it along down to the rest of the stack. Middleware also needs a call method that takes that env environment. Middleware comes between the client and the server, hence middle in the name, but this lets us do things with the request and the response before returning back to the server. We have the ability to process the request before sending it back to the server and down to the middleware until the response is eventually returned back to the client. So here we can process the request. I'm just adding a custom HTTP header, and we can also process the response. I'm just shoveling in a string to the response here. So now that we've seen the promises of Rack, what middleware is, let's dig back into that TIL app. These are some of the features that we're going to be going over as we dig into the development process of this application. There are so many other things that we could add to this, but we're limited for time, so as we transition into the practical part of this talk, we'll just dive right into the development process. Our adventure begins with my very first commit to the application. At the heart of the app is the app class. This is where the foundation is. We're using Rack Builder to set up our Rack app. The run method specifies a simple lambda that responds with that 200 status code, empty content headers, and a string saying TIL. The call method ensures that our rack application is launched, making it ready to handle incoming requests, and it's a simple yet crucial piece of the puzzle. Believe it or not, this tiny script is all we need to actually run our rack application. It's in our config.ru file. It requires our TIL application, it launches it. We use this config.ru file and use the run method passing in our application, and then we can use that bin rackup command to kick things off. So here is our application. Pretty cool. I think we're done, looking good. All right, so after getting my initial rack app up, I thought it was time to bring in some style. I added slim templates for rendering. My choice in this was primarily motivated by which will look cleanest in screenshots. And now in our rack application, we still only return that one response. But now we're doing more than just returning a static string. We see here we've replaced the TIL string with a call to a render template method where we're passing in the name of the template as its argument. In our render template method, we're finding the template in the views directory by the name parameter, and then running that through the slim template render implementation. This will spit out a string of HTML with any dynamic content interpolated. Our config.ru file has also changed just a smidge. I've introduced this rack static middleware. This will handle our static assets for us. I've created a public assets directory for storing the CSS that I created for this app. Please don't view source if you have a deep fondness for well-written, semantic, or idiomatic CSS. I'm not a front-end developer, and I did my best. Here's our new index.slim template. It's basically just a shim for our landing page, so it looks right, but it doesn't have any actual practical functionality yet. And this is where our rack static middleware piece comes into play. Rack will know how to handle our style sheets. It will know to look in the public directory to find it. All right, here we are, looking pretty good. At this point, any URL we go to will return this page because it is our only response that the application knows how to return. It will always be a 200 HTTP status code and will always return the index view. So to add a new route, we just need to map it in. Our TIL route is what we're adding next. We're using the same render template method. We're sending the TIL template's file name as the argument. And so now we've got shims for both of our pages, and we're ready to start adding some functionality. The updated config.ru file. This is where we're going to go when we want to add persistence. I'm doing this with SQL's ORM as well as Postgres. And for anyone who threw an acronym out there, Object Relational Mapper. It's like Active Record, but it's called SQL. SEQUEL. The SQL.connect line establishes a connection to our database, seamlessly integrating into our application and allowing us to have persistence. Now, our actual app.rb has changed quite a lot. Here's the full file after introducing our new routes for posting our learnings, as well as now we're going to be rendering a 404 page for unknown routes. Just wanted to show how big it has gotten. We're going to zoom in on the new things that we've added, though. We established this vital link between our application and the database by allowing us to pass in our database in initialization from our config.ru file. As we move forward, we'll see how we use this database connection. So we're going to next go to our call method. It's kind of our navigator that's going to be guiding our app through all of the incoming requests. In the call method, we have this routing mechanism. As we dissect the call method, we can see how it's channeling requests to the respective destinations. It's doing this by the request path as well as the request method. So here we are at the TIL path, and if the request method is a GET, we're simply going to view TILs. Viewing TILs, we retrieve them, or we set them to an empty array, and then we render the view, passing in that TILs array as a local variable. This will allow us to access this inner slim template so we can have dynamic content. So here's where we're doing, actually using the SQL object relational mapper here, and allows us to abstract away that low-level SQL stuff and have this nice API. We're grabbing the records from the learnings table, excluding those where content is nil, and then we're ordering them by ID. And then here we are in our Slim template using those TILs, and we're able to render a list of them. Next is our creation route. If the request method is a post at the TIL route, we'll run through this method. We grab content params from the request and then insert it into the learnings table in the database. After that, we re-render the index page. This will allow the new learning to be displayed on the page after posting. In our til.slim view, we've added a form to post to this route with the content param. So like I said, we connect to our database in our config.ru file. I didn't include the SQL rake task that I added for database migrations, but the process for adding database migrations and rack in the rake task for SQL is outlined pretty well in their README. So if you're interested in learning how to integrate that into a plain Ruby rack application, definitely check that out. I just didn't think it would be super relevant to include here, but I do have my database as well as I have a learnings table that has the content text column on it. All right, so we have persistence for our learnings, but we also want to be able to augment that counter on the front page. But this didn't seem like it made sense to me to store it in the database because it's not really tied to another record. So what's the table, what's the call, like what are we doing? So I decided to introduce persistence in a different way by creating a text file that will store directly on our server. In our app.rb, we are now setting our counter. We can use that as necessary in the rest of our application. We're setting this to read counter. Read counter is just going to read from our tilcount.txt file and then change it into an integer for us. So we've added a new branch for our root path. If the request method is a post, like we saw with our TIL routes, we will call the increment counter method. Increment counter is very naive, but we're just incrementing the counter by 1, writing it to the file, and then returning the index response. I've also introduced a new static asset, the counter.js file, and added an ID to our button so we can easily access it in our newly created JavaScript script. The counter.js file will send the post request directly to the server, and then also change the counter on the index page in place, giving it the feeling of asynchronous loading. Let's spin up the server and take a look at our application in its current state. All right, anyone see any issues? I'm clicking every time. This is what's happening here. I think it might be time for rate limiter here. That's not, nobody can learn that fast, right? So as our application grows, so does our need to be responsible with our use with it. So we are introducing our rate limiter middleware. This is going to ensure that resources are used widely and prevents any single user from overwhelming the application. So our rate limiter starts off by defining what the rate limit in the time window is. I've decided that I think maybe 10 learnings per minute is appropriate. Every 6 seconds, like that's a pretty high bar, but I don't think we could be learning at a much faster rate than that. The storage here will keep track of the request per session, and then every time we get a request, the rate limiter will check to see if the session has exceeded its allotted request within the specified time window. So we have this like rate limit exceeded method here. And what this is going to do is it's going to assess whether the session has exceeded its allotted request. So first we check if the request is a post method and if the session has recorded any request already. We calculate the current time and retrieve the count of request in the timestamp of the oldest request for the session. Next, we ensure that the time elapsed since the oldest request doesn't exceed the specified time window, and then we assess whether the request count surpasses the set rate limit. As the rate limit exceeded method does its job, it evaluates each request, ensuring that no one session is going to monopolize our application. But what happens when a session reaches its limit? That's where this next method is going to come into play. The update rate limit method, you can think of it kind of as like your log. It's going to record each request And it does that by initializing the session's request history. If it doesn't exist yet, the method timestamps the current request and adds it into the session's history. And if the session's request count exceeds the rate limit, the method prunes the oldest request, maintaining a record of the most recent request. So we've also added some new rack middleware to this. So the rate limiter is custom rack middleware that I wrote, but I'm using this rack session cookie, which is provided by Rack. It's a cookie-based storage so that we can use this for our user sessions. And it's going to be stacked on top of our middleware, our rate limiter middleware, because we need to have access to that inside of our rate limiter. So let's check it out now. All right. Oh, but let's see what's actually happening behind the scenes here. If we go into the console and we check out the network tab, we check out the console tab, we can see that we actually are getting rate limited. It's just not displaying because of our JavaScript file that's augmenting it in place. And here's what you would see in your console as you're running your server. You would see the 10, 200 requests come through, and then you're just going to get 429s after that. So I decided I was going to just create like a cooldown on the button of 6 seconds, and you won't be able to press it in the meantime. So now you press. I also added confetti. That's for y'all. But you're not able to press it again. You're going to be disabled until the 6 seconds have passed. Our application has grown again because now we're introducing WebSockets. So backtrack just for a second. I actually gave this talk for the first time 10 years ago when I was a software apprentice. I was wanting to understand how Rails worked, and I thought that I was going to just be able to like walk through the application, like where does it get started? I'm gonna put a puts in every single map. It was too much. Rails is so huge. But the thing that I found like the most interesting was everything happening in Rack. And that's how this talk originally came to be, was just me digging into Rack, trying to understand it. And now I'm revisiting it 10 years later, and there's new cool things. And so I had to add WebSockets to this. This allows us to get instant updates across all of our clients, like real-time communication. I just think that this is like a super cool thing to know that's like totally available. It is not complex to implement into a plain Rack application. We're using the Fay WebSocket library here. To start, we're going to initialize our connections to an empty array. And then inside of our call method, we're going to check if the WebSocket exists. If it does, then we're going to set up all of these listeners. So we do things like handle events for opening the WebSocket, receiving messages, and then closing the connections, and what we should do when those things happen. When a learning is created, we also are going to call the notify TIL update method after inserting it into the learnings in our database. The notify TIL method is the method that broadcasts to the WebSocket to all connected clients, ensuring that everyone stays in the loop in real time. In our Slim view, nested under a JavaScript colon, we create a WebSocket at our desired path, and then we set up our listeners. So I have listeners for when the WebSocket gets open, we're going to create we're going to get our button when it's clicked. We're going to grab that content, and then we're going to send the content through the socket. When our message comes through, we're going to now at this point, we're going to increment the counter, we're going to reset the form, and we're going to add the new learning into our list. So let's check it out. Let's add something we learned here. This doesn't really prove that WebSockets are working because, right, this is one screen. So we can see when I have 2 browser windows open, and I put my learning on one side, it gets updated on both instantaneously. So, where to next? There are so many options to extend this project and dig into Rack. We didn't even touch on like 1/10 of the possibilities. And just sticking with the standard Rack middleware library provides us with so many important pieces for creating robust and powerful web applications. I highly encourage everyone to go read the Rack docs. And if instead of reaching for a full-fledged framework, it might make more sense to build something totally custom, you should do it. It's fun. But even if you never want to build your own Rack application, just knowing about Rack's role unlocks pieces of other frameworks that might have been fuzzy or never really had thought about. Custom middleware that I wanted to build and didn't get to would have been something like a custom routing middleware so that we could have like a routes.rb file and I wouldn't have to change and add a new case statement to our routes there. That would be my next step, I think. Just to make it more flexible. There's a lot of opportunity for cool custom middleware here. And so I'm actually currently toying with adding this routing layer. Likely we'll push up some PRs to the repo for this. So if anyone's interested in playing around and contributing, or they just want to fork it and clone it, and it's on my GitHub. Of course, I didn't include a link or anything to that on the slide, but I can post it in the Slack. If you like this dive into Rack, then you'll probably enjoy our test double dispatch, because at test double, we are always doing cool things with projects, open source, and we want to share the things we're doing with you. So if you sign up for our newsletter, you will get emails directly to your inbox with cool things. Thank you.